I am Noor, Maths faculty of IIT. Now, in this session, we are going to study part of a complex number. The subtopic is Triangle Inequality. So here we are going to study the different form of triangle inequality and how to solve the problem which are coming in the JEE exams. Okay. So now, in triangle inequality, there are different forms. The first formula is look like this: mod of a minus c lesser than equal to mod of a minus b plus mod of b minus c. So let us try to understand what the formula says. So here we are taking the coordinate axis, and suppose I am standing here at the point A, and A is a complex number. From A, I want to move to the point C. So how much distance I covered here? The distance is A minus C. A minus C modulus. This distance I covered from A to C. Now, without moving from A to C, if I go from first A to B like this, then B to C. So what will happen? The distance from A to B is mod of A minus B, and distance from B to C is mod of B minus C. Now in a triangle, sum of two sides always greater than equal to third side. Okay. So this will be lesser than equal to this one. So third side length always less than equal to sum of the two opposite sides. Okay now? Sum of the two sides of the triangle. So now in this formula, if you observe that there is a equal to sign also. So in which cases we have the equal to sign. Okay now? So now let us explain where we have this equal to sign. When this A minus C will be equal to mod of A minus B plus of mod B minus C. Suppose if I am moving from the point A to C, from the point A to C, and B is a point on this line joining AC. B is anywhere on this line segment AC. So in this case, the distance between A and C, which is A minus C modulus, which is same as the distance of AB plus distance of BC. So in case of inequality, equal to sign will occurs when these three complex number will be on the same straight line. Hope all of you understand this concept. Now this formula, if I consider this one as complex number Z1, and this part if I consider as complex number Z2. So when you add Z1 and Z2, what will happen? B and minus B cancel out. So as a result, we have A minus C, which is this one. So in the next slide, this formula we have. So from the first one, what we consider that A minus B equal to Z1. So in the previous first formula, we have A minus B modulus less than equal to, this one is A minus C, A minus B plus B minus C. So if I consider this one is Z1 and this one is Z2, so what we have? Modulus of Z1 plus modulus of Z2, and their addition is Z1 plus Z2. So therefore, mod of Z1 plus Z2, this is the second form of the inequality. So Z1 plus Z2 is written as less than equal to mod of Z1 plus mod of Z2, where Z1 and Z2 are the complex numbers. Okay. Now here also we have the equal to sign. So in which cases we have equality sign. Now suppose if we have the complex number like this one is a complex number z1 and another complex number from here to here is z2. Okay now? So in this case what will happen, if you add them you will get the equal to sign. So mod of z1 plus z2 which is equal to mod of z1 plus z2. The condition is the complex number z1 and z2 will be on the same line plus they have the same direction. They have same direction. So if we satisfy these two conditions, then we can say that equal to sign will happen. And in this case also you notice that since both the complex number having the same direction and their line of supports are same, so you can also say that argument of z1 is equal to argument of z2. In the next class we will teach you what is the argument. This is the angle made by the complex number with the positive direction of x-axis. So now again taking the first slide, this formula from where we start the triangle inequality. So from 1 we go to the form 2 mod of z1 plus z2. Now from here we will go to the third form of the triangle inequality. So here we consider this part is z1 and this part is z2. So taking this formula from where we get this third form, so initially we have the form 1. Form 1 says that mod of a minus c is lesser than equal to mod of a minus b plus mod of b minus c. Okay. Now you consider this part as z1. This part if you consider z2. So now z1 minus z2 is what? z1 minus z2 a minus c minus of a minus b. So you are getting b minus c. After cancellation of a, you will get b minus c. So here we can write mod of z1 lesser than equal to mod of z2. And this part is mod of z1 minus z2. If I shift mod of z2 on the left hand side, it will be mod of z1 minus mod of z2, which is lesser than equal to mod of z1 and z2. So this formula is true for every z1 and z2. If I switch between z1 and z2, what will happen? If I switch z1 and z2, that means if I interchange in the place of z1 z2 and in the place of z2 z1, what will happen? We have the formula z2, this mod of z1 lesser than equal to mod of z2 minus mod of z1. But we know that the distance between z2 and z1 is same as distance between z1 and z2. So we can write this one as mod of z1 minus z2. So from here, these two equations, what we observe that. So here you notice that if I consider, give you the one example so that you can catch this idea. Suppose one number x which is lesser than equal to 2. Another number, the same number x with negative sign lesser than equal to 2. So if we combine these two, what we will get? X is lesser than equal to 2 minus x is less than equal to 2. That means I want to say that the numerical value of x is always less than 2. So here also having the same things. If you take minus sign common from these two number, then what will happen? You have this kind of inequality. So if I combining 1 and 2, we can write the mod of z1 minus z2. This mod lesser than equal to mod of z1 minus z2. So this is the third form of the triangle inequality of the complex number. Now when this equal to happen, when the equal to sign happen, so suppose here we have a complex number, suppose z1 in this direction and suppose O to P direction. the PO direction, there is another complex number, that is Z2. So if two complex numbers have the same line of support but their directions are opposite, then you have the equal to sign there. Okay. So therefore this formula will be mod of Z1 minus Z2 modulus, which is equal to mod of Z1 minus Z2. This one. Okay. So I hope the concept of the triangle inequality in the three different form, all of you understand when the equal to sign and when the less than sign will happen. Okay now? Now coming to the one important results regarding this inequality. Suppose we have mod of z minus a less than equal to r. What does it actually mean? So in a simple way, you can just see this picture and try to relate the story with this formula. And suppose one goat is here and this goat is tied with a rope. At this point, at this pole having a complex number A. This pole, its position is the complex number A. Okay now? And the goat, this goat you have to consider the complex number Z. And Z is the moving point. Z is the moving point. This pole is the fixed point. This pole is the fixed point. Now, if you allow this goat, which is tied with this rope, and the length of the rope is r unit, that you can move around this pole. Now, what will happen when this goat moving? It will form a circle, and all the grasses the goat can eat. So therefore, this type of things actually gives what? It will gives you this whole circle. This whole circle you are obtaining from this equation. So this is actually the moving point Z. Z is the moving point. This point is the fixed point that we call the pole. And this is the rope, which is the radius. I hope this part is clear. So when we have this kind of things, suppose mod of Z minus I lesser than equal to 2. So if I ask you, what does it say? So it is actually a circle. It is actually a circle, and radius is given as I. This is the center, which is given as I. This is the moving point Z, and this is the radius. So therefore, we have from here radius 2 unit. Center of the circle is I. I is the imaginary number. So 0, 1 is the center. So 0, 1, you can say that I. So now this whole thing, this whole portion is the locus of the point Z. So this equation actually represents these things. Okay. Instead of less than, if it is equal to, what does it actually mean? Consider this figure. There is an ox, and this ox here it is slightly bent, but you have to assume that this rod will be like this one, whose length is given as r unit. Okay, and there is the some machine from where we extract the oil. This ox is actually the moving point Z. This pole is the complex number A. Now, when this ox is moving around the pole, you will get the circle. But here, you don't get any portion inside the circle. What we actually have, we have this boundary point. Because due to this rod, it is not the rope, it is rod. So for this rod, what will happen? This ox cannot enter into the field, into the circle. So therefore we have this boundary. So in mathematics, if mod of Z minus A is equal to R is given, so what does it actually mean? This is the position of the ox moving point, this is the center of the circle, and this is the radius of the circle. So if I give you one example, suppose Z plus iota is equal to 5. I am asking you, what does it geometrically mean? So you have to say that it represents the circle. Circle means here only the circumference. Circumference represent, and center of the circle is minus iota, because your formula is z minus a. So you have to arrange it z minus of minus iota. What is the radius of this circle? The radius of this circle is 5 unit. I hope this picture is clearly understand everyone. Now coming to the next part, the application of these results. Here one equation is given, z minus a is equal to z minus b. Modulus of z minus a is equal to modulus of z minus b. So what does it actually mean? Suppose that this end, here is a one complex number, fixed complex number a. At this end, another fixed complex number is b. Now your moving point z is this ant. When the ant is here, now it is equidistant from these 2 points. When the z is moving, when the z, that means ant is moving upward or downward direction, so every time the ant forms the isosceles triangle. And in case of isosceles triangle, what we have, these sides are same. That means this position, at every position on this perpendicular bisector, the distance of the ant from these 2 ends are fixed. When the ant is here, that means your z is here, then what will happen? These and these 2 lengths are same. So that means when ant moving along the perpendicular bisector of the complex number joining a and b, then every time this ant is equidistant from the a and b. So it is actually, its locus is the perpendicular bisector of the point joining a and b. So it is perpendicular bisector. Perpendicular bisectors of the points a and b. So if I ask you, what is the locus? What do you mean from this? By giving one example, suppose z plus z minus 1 is equal to mod of z plus 1. If I ask you, what does it actually mean geometrically? So it is simple. Suppose it is our x-axis, z plus 1, so it is nothing but indicate the distance of z and minus 1. You can write z plus 1 as z of minus 1. The point is minus 1. Now z minus 1 is the distance of z from 1 to here is the 1 point. So z is such a point which is equidistant from minus 1 and plus 1. So where z lies? Z lies here. That means between minus 1 to plus 1. This is the perpendicular bisector along which our ant is moving. So now it is plus 1, it is minus 1, so this is 0. That means it is the imaginary axis. So locus of the ant is imaginary axis. That means you can say that x equal to 0. Imaginary axis or y axis where x equal to 0. So I hope this idea is clear. With mod of z minus a is equal to mod of z minus b, geometrically it indicates the perpendicular bisector joining the complex number a and b. So all of you understand this. Now we go for some problem based on this idea. From simple to advanced, we are moving. So first of all, question number 1. Mod of z minus iota is less than equal to 2. What does it indicate? Second question. 2z plus iota is equal to 5. What does it indicate? And third question is 2z plus iota is equal to 2 times of z minus iota. What does it indicate? Okay, now, so first of all, it is similar to our given result, similar to the result this one. Mod of z minus a lesser than equal to what? So mod of z minus a lesser than equal to r. So it's actually a is I, r is 2. So what we get, it is the circle and its center is iota, or you can say that 0, 1, and radius of this circle is 2 unit. What about this one? It is similar to our this ox problem, ox formula. So here z minus a should be there. Okay now? So now you have to take 2 common so that the coefficient of z becomes 1. So it will be 2 times of z plus iota by 2, which is 5. So in the next step you can write 2 times of z minus of minus I by 2 is equal to 5 by 2. I can say these two on the right hand side. So it is similar to this formula. Mod of z minus a is equal to r. So if mod of z minus a is equal to r, it is actually represent the circumference of the circle. Circumference of the circle. Circumference, locus is circumference of the circle, and that circle has the center. Center is minus I by 2, which is similar to 0, minus half. And radius is equal to 5 by 2. Okay. Now coming to the third problem. The third problem is, which is similar to this pattern, mod of z minus a something is equal to mod of z minus b, which is the locus is the perpendicular bisector of the line joining the end points. So first of all, we should write this one in the standard form. Taking 2 common, it will be 2 times of z plus iota by 2. From here to z minus iota. So these two cancel out. So you can say that it is in the standard form z minus a mod of z minus b. So therefore your a is minus iota by 2 and b is iota. So therefore it is the perpendicular bisector of the line joining the point. One is iota. Here if you take iota, or you can take on the y-axis. Okay. So clearly we can draw iota. We can take here, it is iota, and one is according to this one, minus a will be minus iota by 2. So here you have minus iota by 2, minus iota by 2. So it is 1, it is minus half, and if you take their addition, so it will be plus half by 2, so it will be 1 by 4. So that means iota by 4 is the equation of the perpendicular bisector. Okay, or you can say that it is y is equal to 1 by 4, because here 0, 1 by 4. This point has the coordinate 0, 1. This point has the coordinate 0, minus half. And if you take their midpoint 1 plus of half, that is half by 2, 1 by 4. So y is equal to 1 by 4 is the locus of this equation of this J2. Now after basic problem, we are going to solve 2-3 interesting questions. Question number 4. Mod of z plus 5 is lesser than equal to 6. Can we find the z plus 2 modulus? Its 2 value you have to find. One is the maximum value, other is the minimum value. What is given? Z plus 5 less than equal to 6. Now compare this one, what I have taught you in the beginning, that is called GOT formula. So using the GOT formula, you will get here z of minus a lesser than equal to 6. So it indicates circle, center minus 5. So x is minus 5, obviously y is 0. Radius 6. So can we draw a circle with the radius 6 and center minus 5, 0? Obviously we can draw. So now this is our x-axis and this one y-axis. Take minus 5. minus 5 will be here, suppose minus 5, and radius is 6. So it will be, if you add 6 here, it will be minus 11. If you add 6 here, positive, it will be plus 1, like this. So our circle will be look like this. This one our circle. This is the center of this circle. Now what we are going to find out, the modulus of z plus 2 is maximum and minimum value. What is z? Z is every point on this circle. All the points on this circle is the z. Okay. So z plus 2 is actually z of minus 2. So this distance we have to find out when it is maximum and when this distance is minimum. So minus 2 is where, somewhere here is the minus 2 point. Now the question is, z is everywhere in this circle. So when the distance will be minimum, pause the video and think about 20 seconds. If you get the answer, it is okay, otherwise you can see the video. Now, if z is everywhere in this circle, inside the circle and also on the circumference, so if z is here, actually at the minus 2 point, then what will happen? Distance will be minimum. So minimum distance will be 0 when z will be minus 2 position. Okay? So when z is minus 2, you are getting the minimum value. Z is minus 2. Now coming to this part, not it is pointer, it is actually minus 2. It is actually minus 2. I think you understand, this one is minus 2. Now, what is the maximum distance of minus 2 on this circle? So if it is minus 2, then you see that if the point is here, z will be here, then this point will indicate the maximum distance of minus 2 and this point. If z is here, then the distance will be the maximum. So now here it is minus 11, here it is minus 2. Now how can we find out the distance? How can we find out the distance? Now this distance you can very easily calculate this part. This part you are actually calculating. This is nothing but 5 unit and 2 unit, the distance between them is 3 unit. And the radius of the circle, you will notice that it is 6 unit. So 3 and 6, 9 unit. Or you can find out 11, minus 11 and minus 2, you can take the difference also. So maximum distance will be minus 11 minus of minus 2. That means it is 9. 9 unit is the maximum distance or the maximum value of this mod of z plus 2. I hope I am clear. Any doubt you can ask about this. Trying to solve one more important questions. Coming to the question number 5. Mod of z minus 5, this part is lesser than equal to 2. Can we find the maximum value of z minus 10? Can we find its maximum value as well as its minimum value? Both value we have to find. Maximum value and minimum value. So again, you notice that this formula, which we call the COT formula, mod of z minus a lesser than equal to 1, or the same formula is here present. So mod of z minus a lesser than equal to 1. From here you have the conclusion that our figure is circle, locus is the circle. After locus you are getting the center. The center is here 5 unit and radius center is 5, 0 and the radius is 2 unit. So can we form a circle with radius 2 unit and the center 5, 0? Obviously we can do. Now this is 5, 0. So 2 unit if you are moving, it is 7. 2 unit left, it is 3. So our circle passing through like this. This is our circle. Okay. Okay. this point is 3, comma 0, this point is 7, comma 0, this one. Now what do we want to find? We want to find what is the maximum and minimum value of modulus of z minus 10. So what is the minimum modulus of z minus 10? The distance between z and 10. What is z? Z is everywhere. Z is everywhere here. But here the radius is 2 units. So z is everywhere on the circle, inside the circle. And what is the next point from where you have to calculate the distance? This one, that is the 10 unit. Now we have to find the minimum and the maximum distance. Will you notice that this point for which you are getting the minimum distance, and this is the point for which you are getting the maximum distance. Notice that. So here 10 and it is 7. So minimum distance will be 3 units. When z at this point here. So minimum distance you are getting 3 units. Maximum distance 3 units plus radius 2 plus radius 2. So 2 plus 2 4, 4 plus 3 7. So dear student, will you notice that without solving any problem mathematically, just by using the figure, we are solving the questions that are generally coming JEE. Okay, now in the next class we will do more and more problems which are based on JEE mains and advanced. Till then, bye, have a nice day. Any query you can ask me and send your query in my mail ID also. Noor Alam 1729 TIGPS .in. Noor Alam 1729 TIGPS.in.